Good evening, students. Today we will discuss about chapter number 12 of your book Electricity, which belongs to topic physics. Before going in detail, I would like to say that spread the knowledge by sharing, subscribing and liking my videos. Okay, and other videos are also available on chapter number 1 and 6. I make it with real hard work, so don't forget to subscribe it and like it. Right, let's start with it. In the recent times, life would be impossible without electricity. We all know that electricity is life for us. It is used in our homes for charging our various devices like batteries. It is used in industries to run various machines, in transportation. Therefore, it has become an integral part of our day-to-day life. Without electricity, we cannot think of passing our even one day, right? First of all, I would like to show you one picture here. As you can see here, this is a picture of electric conductor, that is wire. This one and this one, they are structure of electric conductor, that is a metallic wire, in which these orange circles, they represent metal ions present in them. For example, they may be silver ions or they may be copper ions, of which the metal wire is made of. And along with that, in between those metal atoms are present free electrons. These blue color are free electrons present in them. So this is a general structure of any wire. And if electric current is not flowing through any wire, these electrons, they keep on moving in a random direction. They are moving in haphazard direction. Some of them are moving in downward direction, some in upward direction, some on left side, others on the right side, so that they cancel out electric effect of each other. Therefore, you don't observe any electrons or electric current to flow through it. Whereas when we join this wire with the two terminals of a battery or a cell, in that case, now look what happens. All the electrons, they are aligned in one direction only. They are moving from left side toward the right side. This means terminal of battery on the left side is positive and on the right side is negative, right? So this is a structure of any wire. Therefore, this flow of electrons through any conductor like wire is known as electricity. So this flow of blue color electrons present here is called as electricity. Let us see some very important terms related to electricity. First of all is charge, which is represented as capital Q. Charge is nothing else but is a characteristic unit of matter by means of which matter experiences electrical forces. जो कोई भी matter हो, चाहे वायर है या कोई और कंडक्टर है, जिसमें वो electrical forces को अनुभव करता है, feel करता है, that is called as a charge. This charge can be a negative or a positive. Negative charge is known as electron, whereas positive charge is known as proton, as you already know that. The SI unit of charge is coulomb and it is represented as capital C. Okay, this is a general information about it. Let us see formula to calculate charge. So net charge is equal to number of electrons multiply with charge on one electron. This means in a piece of wire, if we want to find out what is the total charge on it, we can take number of electron multiply with the charge on one blue single electron on it. Right, therefore it becomes Q is equal to Ne. And students, you know that this E is always constant. Charge on one blue color electron or one electron is always constant, that is 1.6 into 10 power minus 19 coulomb. When we put the values, we will find that N, which is found in the 1 coulomb of charge, that came out to be 6 into 10 power 18 electrons. This means if charge flowing is 1 coulomb through a conducting wire, the number of electrons which will flow along with it, they are so many, that is 6 into 10 power 18 electrons will be there. Now this is a general information. I have collected it together for you for your convenience. That is charge Q, SI unit coulomb represented by C, and this is a definition of it as we have discussed right now. Okay, now number of electrons I have written here 6 into 10 power 18. Net charge, this is a formula of it, that is Q is equal to N into E. So don't forget that this quantity is represented as Q, and its unit after calculating is, we'll put its unit, that is Coulomb C, since it is discovered by scientist Coulomb. Now next important quantity is current, which is represented by letter I. Rate of flow of net charge is called as current. Now rate means that divide by time. This means the net charge. What was the net charge or what was the net Q through any conductor? If we divide it with the time for which it was flowing through the conductor, then we can calculate its current. That is why we call it rate of flow of net charge is called current. Or we can also say that electric current is defined as the amount of charge flowing through a unit cross section in per second. It is denoted by I, and its unit is ampere, denoted by A. It was discovered by Ampere scientist. That is why for his honor its unit was named as A. Right, so quantity is represented as I, whereas unit is A here. Now formula again for the current is charge upon time, Q by T. 1 ampere is the quantity of current flowing through it. When we pass 1 coulomb of charge for 1 second only, then it is known to be 1 ampere. 1 ampere is not the only unit to measure current. There are other two units also. One of them is milliampere and another is microampere. Milliampere is represented as small m into capital A, that is 10 power minus 3 ampere, and microampere mu A, that is 10 power minus 6 ampere. Right, so 1 by 1000 part of the ampere is called as milliampere, whereas 1 by 1000 part of the milliampere is called as microampere. Now this current is measured with a very special instrument called as ammeter. As you can see here, this is a diagram of ammeter. It is a meter with a meter scale or graduated scale on its face. As you can see, it ranges from 0 to 10. So there is a graduation scale, and it will measure current in amperes, as it is written as A, so it will measure current in ampere. You can also see two knobs here. One is a black and another one is red. This black knob is negative terminal of it, and this red is positive terminal of it. This means when we will connect this ammeter with the battery, black color end of the battery will be connected with the black color terminal of the ammeter through a wire, and red color terminal will be attached to the red color terminal of the battery through a wire. Now this is represented as like this symbol. Okay, and one thing very special about it is that ammeter is always connected in series or in line with the circuit. If you make any circuit, always connect ammeter in a series or in line. Reason is that ammeter has very low resistance or almost zero resistance, because if it has zero resistance, it will not withdraw any current out of the total quantity of current. So total current quantity will always remain same, since it does not have any resistance in it. That is why it is put in series. Now next is, let us see some of the questions based on it. If 20 coulomb of charge passes a point in a circuit in 1 second, what is the current? So we are with charge and time, we can easily put the formula and find out I is Q by T, and the value is 20 ampere. If we go to the next question, current of 4 ampere flows for 10 seconds, how much charge will flow? Now we want to find out charge out of it. Let us see, I is given here, time is given here, we'll put here formula, and Q will come out to be 40 coulomb. One thing is there, if we want to find out current, always put I here and unit used is A. If we want to find out charge, we are using quantity Q and its unit is always coulomb C. Okay. Now next one is direction of current. This is very important aspect. Current is generally of three types. One is called conventional flow of current. Another is called electronic current. Okay, as we have discussed in the first diagram, that when these electrons or blue particles, they are moving haphazardly in any direction, since they are not attached with any battery, there is no direction of flow of electricity in it, so we won't be able to detect it. Whereas a conventional current always flow from the positive terminal toward the negative terminal of the battery. Now this is positive terminal to negative. Why? Because in earlier years, when conventional current concept was coined, current was thought to be a positive charge. So if it was positive charge, this means it would flow from the positive end toward the negative end of the battery. So it is still kept in the various diagrams, but nowadays we know that electrons or electricity, they carry negatively charged electrons which flow from the negative end toward the positive end, and we call it as an electronic flow or electronic current. So there is a difference in the conventional current and electronic current. They are just opposite to each other. Now I have again compiled this the whole information of current I in the form of a table. A rate of flow of net charge is called current, represented by I microampere, and 1 ampere definition is there. Now conventional current flows from positive to negative, and ammeter is an instrument to measure the electric current. Milliampere 10 power minus 3, and SI unit is ampere, which is denoted by A. So you'll get every information in a one go. Now let us see third one, that is a potential difference. Till now we have discussed two important quantities. One is electric charge and then electric current, which is formed from the charge only. When it flows for some time, then what is formed is a current. Now third very important aspect for the current to flow through a circuit is a potential difference. For studying that, let us see this diagram in which I have compared flow of water and flow of electrons. Flow of water through the tap. As you can see here, at the tip of it there is a high pressure of water, and as you switch it on, the water will always flow in the downward direction, that is toward the low pressure. And if we look at the electronic flow, we will see that this is a positive terminal. This knob is a positive terminal of the battery, whereas the opposite end is a negative terminal. Positive terminal always has a high concentration of electrons. A reason being that this is positive in nature, and electrons, they are negative, they will be attracted towards this end. That's why their concentration will be very high at this end. Therefore it will be at a high potential, whereas the other end will be at the low potential. So certainly it will be driven from the high potential to the low potential, but for that chemical energy stored inside the battery will be used up, that is in the internal circuit, whereas electrons will or current will keep on flowing through the bulb and through the keys, and then through the wire through the external circuit. Let us see what is written here. Water can only flow when there is a difference of water pressure. Water flowing through a tube, it is only possible when there is a high pressure at one end and the low at the other end. The electron can only flow when there is a difference of electric potential. In this case, electric current, the flow of charge is made possible due to the chemical action within the cell. So chemical action is very important so as to flow electrons from one end toward the another end. Students, I would like to say that there is a difference. Let us say that this point is at a 1.5 volt and the other point was at 0 volt only. Okay, so that was a potential 1.5 volt and 0 volt. The difference between them is called as electric potential difference, and that come out to be 1.5 volt. that is a difference between the high potential and low potential, that is 1.5 volt. And only this maintains, when there is an electric potential difference, that maintain the flow of electrons from the high potential toward the low potential. More the electric potential, more will be the current flowing through it. Okay, let us see this diagram first of all. Now I have shown here a voltmeter. Now this voltmeter is used to measure electric potential difference. Okay, you are looking here two terminals, positive terminal and negative terminal here. Right, this positive terminal will have high concentration of electrons, whereas negative will have less concentration. From here, from the, if you look here, this is a positive end of the battery, okay, which is attached to the positive end of the voltmeter, which will measure the potential difference between these two ends. This is positive and negative end of the battery. Okay, now this positive end, from positive end, work will be done to carry this electron in the outer circuit through the wire, and then through the switch, and then through wire, fuse, and then again wire. This will pass through to the bulb, which will help it to glow, then will come back through the wire, and ultimately it will reach to the negative end. Okay, so much work is done to drive electrons in the external circuit at the expense of chemical energy. Okay, so electric potential at this point, electric potential is the work done in carrying a unit positive charge from infinity to a particular point. एक पर्टिकुलर पॉइंट से दूसरे पॉइंट तक जब हम चार्ज को लेके जाते हैं और कितना वर्क डन होता है, that is called as electric potential at that particular point. So it has its own electric potential, whereas negative will have its own electric potential. Okay, so when we find out, when we take a difference of them, electric potential, that is called as electric potential difference, and this electric potential difference is shown in voltmeter, which comes out to be 12V here. This means it might be 0 here, electric potential, and it might be 12 volt here, so that the difference, electric potential difference, came out to be 12 volt between them. So the bulb will grow with that much power. But if we increase it, suppose it is 0 volt, this is 24 volt here, right, which is by using more powerful battery. So 24 volt potential difference will be shown here. In that case, bulb will glow with a much brighter power. So you will see that as we increase the potential difference, current value will also increase, which is shown by the glow of bulb. More the glow of bulb mean more the current flowing through it, and that is directly proportional to the potential difference shown here in the diagram. I hope you understood it. So electric potential difference is the difference between two terminals of the battery, difference in electric potential of two terminals of the battery. Let us discuss about details of it. Electric potential is equal to work done upon quantity of charge moved. How much work is done to move a particular charge from one end to another. That was the definition. So that's why its formula came out to be V is equal to W by Q. So हमारे potential difference का formula हो जाता है V is equal to W upon Q. कितना काम किया divided by कितना charge हमने use किया उसके लिए. So SI unit इसका होता है potential difference का volts denoted by capital V. A reason being, this was named after Alessandro Volta, who has discovered it. Alessandro Volta ने इसको discover किया था, इसके नाम पर है ये. That's why 1 volt. Let us discuss what is definition of 1 volt of potential difference. 1 volt of potential difference is such a potential difference to carry, that is 1 joule of work done, to carry 1 coulomb of charge from positive terminal of the battery toward the negative terminal. So 1 coulomb charge we have to move, and if we use only 1 joule of energy to carry that charge from one end to the another, in that case we call it 1 volt only. So that's why 1 volt is when 1 joule of work is done. in carrying 1 coulomb of charge from one point to another of a current carrying conductor, then the potential difference is said to be 1 volt. Then next is voltmeter. As you have already seen yellow color voltmeter, this is again an instrument which is used to measure potential difference. Ammeter was used to measure current value, whereas voltmeter is used to measure potential difference value, and it is represented by this symbol V in an electric circuit. It is always connected in parallel. One thing to be noted is that voltmeter is never connected in a line or series. It is always connected in parallel to the point in which we want to measure potential difference. And you know that we always measure potential difference across resistances. Now what is resistance? Resistance is nothing else but it may be resistance used in fan or bulb or tube light or heater or geyser anywhere. So voltmeter has a very high resistance, and next thing is that it has very high resistance, so it does not at all allow any current to flow through it, since it has very high electric potential in this resistance. Now this is again a compiled chart. Electric potential difference, that is voltmeter. That is a definition of it. Voltmeter is used to measure potential difference. Now this is a formula of it. Work done upon quantity of charge used. SI unit of it is volt, denoted by capital V, and when 1 joule of work is denoted in carrying 1 coulomb of charge, in that case we call it as 1 volt only. So this is some of the compiled information for your ease, for your convenience. Okay, so that you can pick up the answer or evaluate answer out of it. Let us see, students, let us see next questions. Some of the questions out of it. How much work is done when 1 coulomb of charge move against a potential difference of 1 volt? कितना काम हमें करना पड़ेगा जब हमें 1 coulomb चार्ज को मूव करना है, एक पोटेंशियल डिफरेंस अगर 1 होना चाहिए. So potential difference is 1 volt, charge in 1 coulomb. So our formula was V is equal to W upon Q. Therefore W is P into potential difference into charge moved. That came out to be 1 joule only. Okay, now next question. Name a device that help to measure the potential difference across the conductor, that is voltmeter. Next, how much energy is transferred by a 12 volt power supply to each coulomb of charge which is moved around a circuit? कितनी एनर्जी हमें सप्लाई करनी पड़ेगी अगर हमें 12 वोल्ट पावर सप्लाई का यूज़ करना है हर एक कूलम के लिए, for 1 coulomb only. So that came out to be 12 joule by the same full formula as we used above. So students, we have discussed 3 very important properties of electricity. First is charge, second is current, third is electric potential difference. Now fourth important thing we are going to talk about, through which the electricity or electric current flow, is electric circuit. A battery or cell can make electrons move and electricity current flow. So battery or cell is only the source of electrons in any circuit. You can see here 2 circuits. I have shown you 2 circuits here. This is a real circuit which has a battery and a load, or what do you call as a bulb, which will indicate whether a current is flowing through it or not. Wires are there and a switch is there. Okay, so 3 sources of electricity along with the wire is present here. So current is going to flow through it. When you switch it on, आपने इसे switch on कर दिया है इसे, तो current will flow through it. So it will glow. This bulb will glow. We call such a circuit as a closed circuit, in which there is a closed loop. In all of them we call it as a closed circuit. You can see this is a closed circuit. Whenever I will ask you to make a closed circuit diagram, you need not to make such a diagram again and again. We can represent it in another form, which is called a circuit diagram here. You can see that the same diagram is made here. Bulb can be shown here like this, wire is in this form, then key is in this form, and battery is in this form, right? Now in if we see here, this is a bulb and wire is a wire is here, and key is shown with the circle and a dot in the center, and one cell is shown with the one bold line and a small line. And right now we have how many lines here? 6 lines. This means 3 cells are used here. This is first cell with 2 lines, second cell with another 2 lines, and third cell with another 2 lines here. So we have 3 cells present here, and the current is of course conventional current. We will show from the positive end toward the negative end. Students, I have placed here ammeter also on the way, that is in a line of it. One thing very important to be noted, that positive terminal, that is a red terminal of the battery, should be connected with the red terminal of the ammeter, and similarly negative, that is opposite terminal, to be connected to the negative terminal of the battery. Now this is what is called a closed circuit diagram. Okay, now this is a closed circuit in which the current is flowing, but if we switch it off, if we switch off this one, what we call it as a switch, if we switch it off, in that case you will find that current does not flow through the circuit, and the bulb will not grow. We will call such a circuit as open circuit. Okay, so there is a closed circuit and open circuit. So there is a difference between them. Current only flows when it is closed. Now let us see some of the circuit diagram. In earlier circuit diagram, I have taken only 5 appliances which are shown in the form of a circuit diagram, but there are other structures also which can be used in the circuit diagram. One cell, if we want to use here, you will use here a bold line and a small line, plus and minus sign. So this bold line is always with the plus terminal, that shows plus terminal. Battery, as you can see here, 1, 2, 3 and 4 cell battery is shown here with plus and minus sign. Key switch open. Now here it is open when current does not flow, whereas if key is closed here, current will only flow through it, through the circuit, and the bulb will glow. Wire joint, when we join the two wires, this is called as wire joint. We represent it like this. Next is wires with no joint, mean wire will pass as such above the other wire. We will show it like this. Next is bulb, like this. Ammeter, plus and minus sign and ammeter sign in the center of it. Voltmeter is shown like this. Resistance is like this. Resistance is in the form of a kink. This is a fixed resistance, whether 5 ohm, 4 ohm, 3 ohm. If we require it, we can get it from the market, but their value is always fixed. We can use it at a fixed places only. But there is another type of resistance also, which is known as variable resistance. Other name of it is rheostat. This is represented like this. You'll make a kink here and an arrow above it. This means we can always change a resistance. We can make it 3, 4, 5, 6. As much current we want to drive through it, we can change the resistance of the circuit by using rheostat or variable resistance. This is of course available in our laboratories. Rest use of the rheostat or resistance I will show you in the further also. Now let us see question related to it. What is a circuit diagram? And draw the label diagram of an electric circuit comprising of a cell, a resistor and ammeter, voltmeter, closed switch. Which of the two has the large resistance, an ammeter or a voltmeter? So our electric diagram is a diagram which indicate how different component in a circuit have been connected by the electric symbol is known as circuit diagram. Now the components we are asked, we have put them in like this. Cell, first we put here cell with plus and minus sign, then a switch of course should be near it, and then a resistor, and then in a series is ammeter. Parallel to this resistor is applied a voltmeter. Okay, and wires are shown, always show direction of current from the positive terminal of the cell toward the negative terminal. But always keep in mind that on a way, when we join an ammeter and a voltmeter on its way, positive end of ammeter, positive end of voltmeter should be facing toward the positive end of the cell, and negative end should be on the other side toward the negative end of the cell. This is how a complete circuit diagram is shown. If we lack in it, definitely marks will be cut out of it. Let us see some of the numericals for your use so that you can practice your questions. Now solve this question. Write down formula which relate electric charge, time and electric current. A radio set draws a current of 0.36 ampere for 15 minutes. Okay, calculate the amount of electric charge that flows through it. So we are with current here, that is I, and then time, which we'll convert it into seconds by multiplying it with the 60. So we will get time period. So formula we will use here is I is equal to Q upon T. In that case we will use the formula and find out what is the value of Q. Second is, in a 10 second, a charge of 25 coulomb leaves a battery and 200 joule energy are delivered to an outside circuit as a result. First, what is the potential difference across the battery and what is the current flowing through it? We can very easily calculate it by putting the formula. Potential difference V is equal to W upon Q. We will use, that is W is 200 joule. Instead of work done we can use energy, that is 200 joule upon divided by charge 25. You can easily find out potential difference, and its unit is volt. What current will flow through it? I is equal to Q upon T. Use that formula and find out the answer. Third one, what is the current in a circuit if the charge passing each point is 20 coulomb in 40 seconds? Again, I is equal to Q upon T. We can use here, so we can find it out what is the answer with it. I hope students you understood the topic here with the basic quantities of which are necessary for the electricity to flow through it. So kindly subscribe, like my videos, okay, so that this knowledge can be spread to, and share also, so that knowledge can be spread to other students also. Thank you very much.